Perfect. Welcome, everyone. This is our third office hour, so bring it on. Any questions? Oh, oh.
Yeah, I had a question.
Yeah.
Um, Sorry, I just had to pull it up real fast. I don't want the answer to the assignment or anything, but just kind of I just want to make sure I was doing the oh man, hold on. Question. So, just sorry, I spoke too soon. Like the variance and standard deviation.
Hmm.
Uh, let's see. I put in Excel spreadsheet. But yeah, basically like the standard deviation, the variance of like those
This
number
is
lists.
question
Just make
three.
sure I was doing it correctly.
All right, I'll let you share screen if you want to show me something, maybe.
I spoke unprepared. I'm sorry.
No worries. We got time.
While you guys do that, maybe I can ask my question. Is that okay?
Oh, yeah,
Go for it.
definitely.
So as I'm finishing up my assignment, the individual assignment,
Hmm.
I have had multiple versions of it, but I'm still not sure if I got it right. I'm not asking for an answer, of course, but I'm struggling with constructing a tree for multiple options, like specifically for the drug thing. I think it's question number four,
Okay.
where it's giving us multiple options like, okay, here's the percentage of us getting zero revenue, here's the percentage of 10 billion, 40
Yeah.
billion, 20 billion, right? So we've seen several examples in class and in videos where we usually have like here's the percentage of this happening and here's the
Hmm.
other not happening. But I haven't seen like four compared, like four things adding up to 100%. So I'm
I
struggling
mean,
like about how to construct more than two. Like, is this happening or not? So that's usually a very binary one. But this is more okay. You go with the biosimilar drug, or you develop
uh-huh.
a brand new one, right?
Yeah.
You know the problem I'm talking about, right?
Yes.
So this is what I'm struggling with, and I'm not again. I'm not asking for answers. I'm just trying to like understand the concept of how to properly treat that. So the decision lies between do we develop biosimilar or do we develop a new drug? So that's clear.
Yes.
But then
Perfect.
once we try to explore the options for the new drug, it's not like, okay, we develop this drug and then the probability of it succeeding is, let's say, zero point 0.6 and then not succeeding zero point 0.4. Here we have four different options. One, the drug is not approved, we get zero, minus
Hmm.
10 billion for development costs. But then the other three options are we do get some revenue and then we subtract the development cost too. So how do we properly and like maybe you can use like any other example that kind of can explain how to
Yeah.
graph that? That would be fantastic. Because I've been racking my brain for 2 weeks now, and I'm still like, it's due today, and I don't know. It's
Yeah,
crazy.
perfect. So how can I not give it up? Okay, let's do the following. So let's say you have one more person. So there you go. So okay, you have a decision to make. You have something here. We don't care about this, and then you have something here. And here you have uncertainty, and you want to know when we have more than two, right? The only difference between just two, or let's say it's like 0.4 and 0.6, is just you have more arms. So like let's say you are investing in a stock option or in a stock, yes, just a stock, and there is a 0.5% chance that it goes to zero. There is a 15, oh, I'll do it more.
Yeah,
There
and then
is
with also how to factor in the cost, right? Like, do we do it at each level, at each
oh
probability,
yeah,
or do we
perfect.
just do it at the end as well? Yeah, thank you.
Amazing. So let's say I need more space. So we have uncertainty. Either let's say you buy a stock and the stock of this, you can do this, or this. So let's say the cost of buying this stock, and it's gonna be, let's call it cost. It's gonna be $10. So there is we said zero. Let's just call it one, so make it easy. 0.1% chance that it goes to zero. We'll add the cost later. I'll color code it just to make it clear. Oh, I don't like the red. That's better for the eyes. So let's say there is a 0.3% chance that it goes to 100. There is a 0.2. Oh, let's do weird numbers. 0. Yeah, also 0.3, why not? That it goes to 150. And this is 6, 7. Oh, this is fun. 0.3 chance that it goes to 250. Okay? That's first how you do the multiple cases. All of these still add up to 1 because it's just the same uncertainty. Okay. And then to add the cost, the only thing you do is the following. So when you're evaluating the possibilities, I have the color I want. I have the color I want. Okay, never mind. Then you subtract from this the 10, 10, minus 10, minus 10, minus 10. Thus, the real payoff here will be 140, here will be 240, here will be 90, and here is minus 10. Okay? Does that make sense? I'll color code it.
Yeah, so what I did was the same as you, except I added all the values after multiplying the revenue, potential revenue by the probability, adding them all up, and then I subtracted the 10 billion in that specific case. But you're saying you should do it at every single level then.
It should, like, the end value here should be the same.
Because
Yeah,
in that particular
algebraically.
problem, I tried it this way, but it didn't make sense to me because if I did that from each level, it was going to be negative in most cases. Or after, yeah, like
It shouldn't be negative in those cases if you have a payoff like this. But like, okay, I'll show you both. So it should be, let me
so
calculate that. Should be this guy.
with our problem, it was 10% of getting zero, so that's negative 10. Then I want to say, gosh, I have to find my notes. I want to say it was like 20% of getting 10 billion, then 40% of getting 20 billion, and 20% of getting
40?
40, yeah.
Yeah.
So after I
So,
did the multiplication and then subtracting 10, they would be like a lot worse than the sure option of, getting 15 billion minus 5. So that was guaranteed 10 billion, right?
a
So
lot
with
worse?
these, well, yeah. So let me just get my notes for quick. One second.
No, 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 no.
Okay, so it was 10% of getting 0 billion minus 10 billion of cost.
Mm-hmm.
30% of getting 10 billion. So that would be 3 billion. But if you subtract 10 billion for development or research, right? That's
I
negative
see what
7.
you're doing. Okay, 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 okay,
So if
okay.
I follow the same thing, like it just stopped making sense to me because I did try that first, but then I was like, okay, well, why would they even like look at this option?
Okay,
There's got to be a catch.
I'll respond it without giving the solution. So the thing that you're doing is like you're giving here the payoff will be without considering the 10 would be 30, and then you're subtracting the 10 instead of doing this here. But like
Yeah.
that's not correct because
Oh,
you're basically subtracting the cost 4 times as if it were something sure and
right.
not as 4 different cases. So like here you also this word you're gonna multiply it by 0.1. So the result here will be like -1. Here this one will be 0.3 divided by 3 times 10 will be 3. Then it will be I don't want to wait 140 times 0.3. One sec. Oh, it's 27. Yeah, 140 times 0.3. This is 42. And this
Or
is
are you saying, I think I might have gotten it, or are you saying that we subtract the cost from the potential revenue before it's multiplied by the probability? Is that what
yes,
you're saying?
exactly. Yeah.
Oh, that's where I screwed up. Okay, never mind.
Perfect.
Because
Yeah.
I did the multiplication first, so 0.1, let's say, or 0.3, I guess, let's go with the positive number. So the second option you have 0.3 multiplied by, 100, then you subtract the 10 after, or that's what I did. But you're saying is don't do the multiplication yet, so you just look at
Yes.
the
First
value
subtract
of
and
100, then
then
oh, okay, okay,
yeah.
okay. Okay, thank you. That makes sense now. Oof,
Perfect.
thank you.
Oh, next one. I don't remember who was doing questions before. I think it's Andrew. Maybe.
Yeah, Leland. Hey,
Leland. Hi, Leland.
hello.
Tell
Um,
me.
Sweet. Yeah, I found it. I changed the numbers so it doesn't. I just want to make sure I'm going through the process correctly.
Okay.
Um, I was trying to do it kind of methodically through like a spreadsheet.
Okay.
These are kind of some given things that they'll give us. Um, so I was kind of going through the process of finding the expected value, and
Uh-huh.
I remember we were multiplying across and
Yeah.
then adding them to get the expected value,
Uh-huh.
and then
V3.
the
Okay.
variance. I was using the expected value as the mean. So
Perfect. Okay.
subtracting that from there, squaring it and multiplying it by this, and then summing up the variance and then square rooting standard deviation. I was just kind of making sure I was in the right process.
So let me see. So X, you're doing B3, which is 0. That's okay. Minus C18, which is expected value, squared, perfect, times the probability, which is, yeah, I don't see problems with your formula.
Oh, okay.
Just
Yeah.
be careful that then you need to square root that to get the standard deviation. But yeah, I mean, yeah, you got it there. Yeah, perfect. You saw it.
Sweet.
And the variance is the sum. Yeah, that makes sense for me.
Oh, okay, cool. Appreciate that. Thank you.
Um, Hi. Um,
Hi.
so where I'm stuck,
Hmm.
it's the on the second part of the decision tree question. And
Okay.
I kind of get that it is that you kind of have to you're making a different decision, so you're starting in a different place. Because it's asking you about research. But
I'm
then
guessing this is the value information one, right? Like
yeah.
B. Okay, perfect.
But that's about as far as I make it.
Okay, so you have been trouble starting the tree out, right?
Yeah, so I do kind of start with the research, no research kind of question. Uh,
Okay.
and then to me, the no research then goes into
I'll
you
start it differently. I will start, I think it's better if you start with the uncertainty. So you have the four options. Okay.
uh-huh.
And then you open a different path. Like if you saw, which one was office hour one? No, review session one. So in review session one, there's a pretty similar exercise. So you have your uncertainty, whoop, whoop, and like that. And then you'll have a decision here, which is the different options given whether to pay or not the research. Because you're not deciding technically to do the research. The question you're trying to answer is more on the length of
The
this is
value of the research.
exactly. So this is not whether to research or not. This is the decision, well, decisions to do the biosimilar one. So like
Got
this.
it. So then I would be doing I guess
It's like
I'm
how much you're willing to pay for research, right?
Yes,
Like what
exactly.
makes sense. Okay.
So
so okay,
yeah,
so it would be bio versus the 10.
I can
One
give you
of
the
the
numbers,
outcomes. Yeah.
but yeah, so that's how you should start the tree and then solve it. And then when you do the expected monetary value with info, and then do the diff with the expected monetary value, well, really horribly, monetary value with no info, then if this delta is bigger than the 1.6, then you can say, okay, it makes sense. If it's not, then it doesn't make sense.
Okay.
Yeah,
I just want to take a screenshot of your.
yeah, yeah. There you go.
Okay, I see it. Thank you.
No worries. Oh, kind of problem with solve with a table. Ooh, that's hard. I don't see. Let me think with a table. That's a hard question. I wouldn't recommend it, Shannon. I don't see how can that make the problem easier. Maybe you have a method that could work, but I would strongly recommend doing the tree. I think it's simpler. No, no worries. That's okay. That's not showing.
Can we go through how to properly use Excel for these wherever that's possible. I've been using this stuff in hand, like formulas and stuff, but I'm honestly not good at Excel. Liberal
Okay.
arts major, so I would love to understand how to set things up in Excel, what kind of formulas we try to use, like maybe some similar problems to like what we have for homework or something else, just
Okay.
concepts, anything, honestly.
Let me get this going.
Yeah.
What's those? Okay, let me open Excel file. Hours. Ba-da-ba-bum. Okay, I'll stop sharing this screen then, and I'll start sharing the Excel file. Okay, let me see how it looks. Great. Here you have time meeting controls. Well, you still see the big squares. That's annoying. Okay, that doesn't bother us much. Nowhere. Need to search for exercises. Give me 1 second. This is regular session. Maybe these ones. Okay, it's better. Exercises. I like this one. Meeting controls. Wait, this works. Office hour 3. That's better. Oh, that's perfect. And more questions. So that's A, B, C, D. And let's get the other ones here. Okay, that worked. So let me start the table. Quality assurance team, a software that it looks right, right? Yeah, it looks right. A software development company inspects different software modules of a new product, then number of major bugs. Okay. So we have X. We have P of X equals X. Let's center those 0, 1, 2, and that's 12. Then it's going to be 0 0.018, 0.073, 0.147, 0.195, and another one 0.115, 0.156, 1.0, 0.260. Okay, I need to have the same. Just give it those numbers. Okay. Great. Let's see. Question A says, what's the probability that 4 or fewer major bugs are discovered in a random module? So we want the probability. I think I'll have it better here. Zoom. I'll put both. That way is better. Okay. So we're being asked. If you have a question, just stop me, Vika. Okay. So 4 or fewer. So x less or equal than 4. This is the sum of these values. Does that make sense? Yeah. Okay. I'll just continue and just stop me if there's any question.
Yes, thank you.
Amazing. And this is question A. Let's do B. What's the probability that at least 5 major bugs are discovered? So at least 5. So this is P of x greater or equal than 5. Go up. And I'll just copy the formatting. Great. Let's do C. What's the probability that more than 3 but fewer than 6 major bugs are discovered? So this is pretty much the same. So we're getting the probability of more than 3. So x greater than 3. Oh, well, I'll do it different. 3 minus x is greater than 3 and less than 6. Right? Fewer than 6. Yeah. So basically these ones. Oh, I want to add them on. Wait. D. Find the expected value of x. Okay, so D. Yeah, I'll do it here. I think it's best. Yeah. So here I'm gonna do x times x times p of x equals x, which is just this multiplication here. Wait, great. And same number of decimals. So this is basically the expected value of x, which is just this sum over here.
Are you able to paste maybe the actual how do you
Formula?
put in this the formula like next to each of them?
Yeah, so I'll add it here. So wait, this is I need to add the ready. How can I write this in Excel? I know. So what we're doing here is make it a sum symbol. Here. Okay. So we're adding up x, wait, x, no, right. If I read another way. I know how to write it better. Oh, yeah, that's way better. So is the sum, I'll add the sum later. Sum of x times on space times. Oh, I know where I want to write it. Give me a second. I'll add a Word document. This one, Control T Alt. Here I can do the symbols. With the sum symbol. Okay, sum, perfect. Sum of x times p of x equals x equals x, and that's equal to
I'm
the.
not sure if it's me, but I
No,
have.
I'm not showing it. I'm writing it in our
Oh,
server,
gotcha.
so I
Okay,
can
no
just
worries.
copy and paste it. Yeah, I appreciate it. Great. That's perfect. The thing is that writing formulas in Excel is slightly annoying. Curious. So I just wrote it in Word. That's way better. Oh, does that work, or you need like a different format?
No, just to like, well, I think more of what the
Like a
formula looks like
process?
in Excel. Like, how do you structure it
Ah,
in Excel?
okay.
Yeah, because
So
you kind of went through it like fast, and I wasn't able to write it down. So like, I was thinking like, okay, I'll screenshot it and then go through it later so I can understand how each one is structured. That way, I can replicate it for other problems.
oh, it's perfect. Yeah, I'll explain it,
Thank you.
And wait, it's better. Let this over. Okay, what I did, let the square be removed. So I added this column. So the expected value of x is just the sum. So I'll just highlight it. Is the sum. I'll give you the Excel just finishing this of this column right here. And the column is calculated as x times the probability of x being x every time. So 0.19 times 3, 0.19 times 4, and so on, all the way. And then this sum is the 4.9 here.
Okay, yeah, that makes sense. Thank you.
Perfect. Okay, then we have E. Okay, it's slightly more longer. I'll write the formula too. So, that formula. So, the variance of x can be written as the sum of x minus the expected value of x. Oop. This squared times p of x equals x. Yes. So another screenshot. Going back to Excel. The meeting controls. All right, there you go. So this one is going to be here. And what's the best way to do this? Yeah. So here we'll do x minus e of x. I'm missing one parenthesis, and then we'll do the same, just squared. Okay, so we know that e of x is 4.00009. So, and x minus e of x is just x minus e of x all the way. There you go. And then we need it to be squared for the formula here, squared. So that difference, we're just gonna, I'll do it the other way. So it's just more clear. Wait, oh, long time. Where is my series? No. Square, that's the English formula. Oop, I have an error. I'm missing one part. Then we're gonna add the times p. Yeah, that's why you're so big. Then we have this, all of that, big parentheses, times p of x equal x. I'll do it just step by step. That's perfect. Yeah. So this one times that. How many decimals? That's 9. I'll reduce, yeah, this one. Just 3 decimals, I think it's enough. Yeah, that's perfect. Center this. Okay. And then we add this up. So the variance var x, and then st of x square root. Okay, I'll explain now. Format. And this is gonna be slightly bigger. That's perfect. So what we did here is just I did a lot of mini steps just trying to replicate this part of the formula. So x minus the expected value squared times the probability, which is so x minus the expected value, then squared, and then times the probability. Okay? And then you add all that up. That's the variance. And then that variance, which is the sum, you get the square root and you get the standard deviation. Yes? No? Questions? I still not saying it. Yes? Just again, no comments, right? Oh, I have it in the chat ID. I haven't seen it. Oh no, never mind. Big I still got you with me. Just checking.
I am, yes. It's just for me, I don't want to slow everyone else down, but for me, it's a little too fast. Where like, if you're typing in the formula and then like we get the answer like very quickly, I
Oh
get
yeah, no
how it's
worries.
done, but then what I need to know specifically is how to go in and put the formula into Excel so I can, render the same kind of
Oh yeah.
answers
So
for each problem.
yeah, no worries. I'll send the Excel either way. So
Oh,
here
cool.
it's
Okay.
just
Yeah, that would be perfect. Yes, that would be actually
perfect.
the fastest way to do this. Yeah, thank you.
Amazing. So the first is just subtraction, just simple subtraction. Then for the square, you do, I don't know how you call it simple, but like that simple. And then for the
Like I'll
probability,
go
just
back and reverse engineer this stuff later, essentially.
perfect. But yeah,
Thank you.
here we're only using like addition, subtraction, and multiplication. It's just deaggregating this formula into steps. Yeah. Yes. Perfect.
Yeah, so I have the formulas, like I've seen them in multiple either like readings or videos. It's just like when I get to Excel, then I'm like, how do I really put that into the cell so it does the same thing? You know what I mean?
Mm. Okay.
So yeah, if you send the Excel file, that's perfect because then I can go in and click on the cell and see the formula then in the function.
Perfect.
Yeah.
Okay. So, question, just to make sure, does anyone else have a question, or we finish the problem with F, G, and H? Just making sure. Okay, no questions. Then we continue. So we have F. Let's finish this. The quality assurance team is interested in modeling the correction time. Oh, zoom in. Not that much. F. Which is therefore in hours required to review the model and therefore required to fix each of the major bugs. The time to review the model is 20 hours, okay, regardless of the number of bugs. So 20 is a fixed time slash a constant. And regardless of the number of bugs, each major bug requires 4 extra hours. which is also the variable part of this variable. Let y be, I'll write that, let y be the random variable that represents the correction time of the module. Okay. So this is just information. I'm gonna move F here and move this on top here. So what's the probability that the correction time is greater than 2 days? So we're asking what's the probability that y is greater, yeah, than 2 days. Which is basically saying what's the probability? It's the same. Okay, I like it. Saying what's the probability of x being greater than, and we're gonna do space here. So if you want to know that's greater than 48 hours, we know that y is defined as, no questions in the chat, questions in the chat. And 20 plus 4x. So then if we have 48, Arlene, tell me.
I do have a question, but it's not on Excel, so maybe after this. I just if there's time.
Okay, I'll finish this incredibly quick and I'll then jump to it. Yeah. Perfect. So I don't hit this leave and I can just deliver you guys. So I'll just be quick. So I'll just get speed. So if it's 48, then this is 48 equals 20 plus 4x. Thus minus 20, that's 28 divided by 4 equal to x. Then you have equals 7. Then you need to say this is greater than 7. That's the logic. Extra space? No extra space. Okay, so this is just the sum of being greater than 7 in probability terms. This. Oh, wrong number. Sum. Wait, Excel. There you go. So I'll do this here. I'll copy this here. Perfect. Let's do G. It's gonna take slightly more time. What's the expected value of the random variable y? So here's just the algebra that we had before. So expected value of y is the expected value of this. So it's the expected value of 20 plus 4x. But we know, and this is just for algebraic rules, well, probability rules, this is equal to, well, I think 20 plus the expected value of 4x e of y equals 20 plus 4 times the expected value of x, which we know e of I equals, I'll do it here, 20 plus 4 times the expected value, which is 4. And this makes sense because format, we know we have to wait always at least 20 hours, and then is the expected is 4 hours per time. Then on average, you spend 4 hours. So 4 times 4 is 16. That's why it's 36. There you go. And let's finish this H. So this is the same process. the standard deviation of y is equal to the standard deviation of the equation here, 20 plus 4x. The standard deviation of y equals, the constant doesn't have a standard deviation because it's a constant, so it's only 4x. Then you do SD of I equals 4 times SD of x. Thus, SD of y equals 4 times, what are you here? We, I'll just 4 times. Okay. Perfect. Okay, that's it. I'll save this now. I'll start sharing the other screen. I'll stop sharing this one and I'll start sharing the other one. Where's this? Share screen, start broadcast, and get to here. Wait, return. There it is. Okay, Arlene, tell me.
Sorry, I was on mute. Okay, so I don't know if you can answer, but on problem number 3, wait, number
Problem.
3, which is actually a lot of the work you were doing just now.
Okay.
For the G section,
Okay.
sorry, for G.
Okay.
I guess my question is the only way to answer it to kind of build out the full table, or is there a formula that can be used? And I don't know if you can answer that.
Okay, let's see. So G is what will the expected value be and the standard deviation of the total bonus payment that sales rep will receive. Okay, let me read this real quick. And this is the sales reps one. Okay. You calculated that before, right? Yeah, in E. Okay, so the question is if there is a formula to solve it, or what's the question? Just trying to make sure.
Yeah, I was trying to figure out, so if the way to solve, because I understand how to figure out what is the expected value and the standard deviation
Okay.
using kind of the full table and then kind of doing all the formulas on the side to
Yeah.
get the individual numbers that x1 or x0, 1, 2, 3, 4. But that's, on a repetitive basis, that's a lot of work. Like, not for now. Like, I mean, we've had weeks to do this. I won't complain about it now.
Okay.
But in a timed test, like, is there a formula? Is there a different way to get to the answer? And maybe I missed it and you were doing it in the Excel sheet.
Okay.
Besides building out that whole table, in essence, because you end up building like 3 or 4 extra columns to get to all of these answers.
Okay, I think I got your question. I'll go back to Excel. So basically, G is pretty similar to these two combined. Okay, So
okay.
because it's asking you, okay, let's say it says like like each prescription or something like that is like $750, right? So your function in that case is just, I don't think this is like telling you the answer, but like it's just 750 times X or something like that. Yeah.
Yeah.
So you're not doing
But don't worry, I
another,
already had that part, so you're good.
yeah, like you're not doing another table to solve this. This you're solving based on the first table you made. Like for example, here, like when we get asked, okay, if or let's say we have a fixed time of 20 and then every extra bug it's 4 hours, and we want to know what's the probability that it takes more than 48 hours to fix something, then you do, okay, the probability of P being greater than 48 is basically, oh, it has to be greater than 7. Why greater than 7? Because you're taking 20 hours for sure. So then you need to know how many bugs does it mean to spend more than 28 hours or more? And then you divide it by 4 because each bug is 4 hours, then it's 7. So you go to the table and say, okay, what's the probability that X is greater than 7? And then it's the sum over here. So
Mhm.
you're not doing another table, you're using the same table you have. Does that make sense? Is that where the question is going, or is another thing?
Yeah, I think so. Except in this tape, yeah, I think so. So in a sense, I have to. Yeah, I think so. I think because the way I've done it through exercises up until this point, or up
Yeah.
until we get to the
Like,
bonus questions, is I
for
built
example,
out the
you
table,
also, yeah,
but I need
okay.
to learn how to use the formulas to plug it back in instead of always building out the table, if that makes sense.
Yes, I agree. Like, for example, here we get
Like
asked
how to back
the
into it, I
expected,
guess.
if you get asked the expected value of y, the only thing you're doing is, okay, the expected value of y is basically the expected value of this function here, which is 20 plus
Yeah.
4x.
Hmm.
And then there's some just algebraic or like probability rules. So you know that is decomposed as 20 plus the expected value of 4x, then it's 20 plus 4 times e of x, and you know from the prior question what's e of x. So it just becomes some small algebraic problem.
Okay.
The same for the standard deviation.
Yeah, for some reason the standard deviation is easier for me to understand because like, it's already there. But I think but for some reason I get okay. All right. I think I got
Yeah,
it. You say you're gonna share this with us later?
I'll share it as soon as we finish. The
Okay.
recording might take a while because it's to process, but like, yeah, you'll get it before 9 for sure.
Okay. That
Amazing.
was it. Thank you.
No
I
worries.
actually just put it in the chat if you are able to share at
Oh,
least the Excel spreadsheet, maybe like the link to like your Google spreadsheets or something.
oh
I
yeah,
have
let
to
me.
redo some of the stuff that I did for homework because it's definitely wrong now.
No worries.
And that's due very soon. Thank you.
I'll share it now. It's just submitting the Excel sheet now.
Awesome,
Just
thank
making
you.
sure it's. So we have, okay, this is office hour 3. Office hour 3. Let's close this. Um, office hour 3. Perfect. So I'll submit it now, given that we have time. I'll stop sharing screen here. Perfect. So, oh, screen broadcasting. Okay, that's perfect. So let's see. I'm sharing right now. Oh, yeah, I'm lagging the screen. That's nice. Gallery review. Lovely. So office hours, video and notes. Office hour 3. Okay. Edit. TA 3. XM underscore file. XLX. Perfect. Save. So you should be able to access it now if you go to the office hours materials. If you can check, that would be great.
Yeah, I'll go check that right now just to make sure it's there for all this.
I see it. I'm just trying to
Perfect.
see yeah, it's there.
Amazing then. So that's it for today. Thank you so much for being participant. And yeah, just any more questions, just email me. But good luck with the assignment, I guess.
Wait, sorry guys. How do you find it again? Because I see.
So if you go to the homepage
Uh-huh.
in Ruinlearn, at
Yeah.
almost the end in the office hours section, there is a small comment that says video and notes. And if you click it, it's gonna take you to the office hours materials.
Oh, okay. Because I was seeing the Zoom link, but okay. Let's see. Got it. Yes. Thank you so much.
Amazing. Well,
Super
ahora se
helpful.
encuentra
Thank